You would often find questions around array in DSA rounds if you are appearing for a front-end interview. Don't worry, I am here to help you crack your dream job. My name is Vedant and you are watching DSA in JavaScript on JS Cafe. So without wasting any time, let's get started. So today we are going to solve a very famous question on Canada's algorithm, that is maximum subarray. So the question states that given an integer array nums, find a subarray with the largest sum and return its sum. Okay. So what is a subarray? Subarray is a contiguous non-empty sequence of elements within an array. So subarray means that it has to be contiguous, so you cannot skip any number in between. For example, 2, 1, minus 3, 4 is a subarray. Okay, so the subarray cannot be like minus 2, minus 3, 4 and we omit 1. Okay, this is not a subarray. So subarray states that it has to be contiguous non-empty sequence of elements. Non-empty means that at least there should be one element inside the array. So the question finally tells us that we have to find a subarray. Actually, the description is misleading a little, because you don't really have to find the subarray. You just have to find the largest sum from that subarray. Okay, so don't get into the run of finding the subarray. Okay, that in that way you will get onto a different path. Okay, that would be a wrong path for you. What we need to find is we have to focus on the largest sum. So we will create a variable sum that will keep track of the largest sum as we progress through each element of the array. I will explain all of this on the whiteboard and it will become much clear to you. So let us copy this example, and the subarray is, and the largest sum is 6 actually. So this is how it is. Now let us try to see and what is the value. So we have this array for us. Now let me grab my pen and let's solve this question. Cool. So what we are going to do is, initially I will create a variable called as maximum mx. Okay, and I will be assuming that initially the maximum value is the array is the value of the array at index 0. Okay, let us assume that. So maximum is -2 at the beginning, and I have a value sum initialized to 0. Okay, which means that like this sum is the sum of all the numbers for a subarray. Okay, this is a placeholder for it. Initially I'm initializing it to 0. Okay, initially, because we don't have any element, and I will start iterating through each element. Okay, so we start with element -2. Okay, we start with -2. So we add -2 to the sum. The sum becomes -2. Is -2 greater than the value mx maximum, which is not the case, so we will not update the maximum value. Okay, we will leave it as it is. Now the sum value is -2. Okay, sum value is -2. Is this value less than 0? Yeah, it is less than 0. So we should initially bring it back to 0, because carrying a negative sum is of no use for us. Okay, you have to understand this. What we are trying to do is we are trying to find the maximum sum. We actually want to maximize this placeholder sm. Okay, if this sm is somehow a negative value, then it will not make any sense for us. So that is why if at any place the value of sm becomes less than 0, we will reset the value of sm and initialize it to 0. Okay, this is the step we are going to follow. So initially we traversed for -2. Now we will traverse for 1s. So 1 plus sm, the value of sm becomes 1. So value of sm becomes 1. 1 plus 0, 1. Is 1 greater than maximum? Yes, it is. So we will update the value of maximum with 1. Is the value of sm less than 0? No, it is not. Then we will not update the value of sm to 0, and sm would be 1. Okay, the sm is 1. Now we come to -3. Now we add -3 to sm. So sm will now become -2. Okay, Now we will check that if value of SM is greater than the value of maximum, it is not the case, and so we will not update the maximum. Now we check that if value of SM is less than 0, if it is less than 0, then update it to 0. So SM becomes 0 over here. Okay. Now we will check for 4. So we will add 4 to SM. SM was 0, so we add 4 plus 0 becomes 4. Is 4 maximum? Is 4 greater than maximum? Yes, it is. So we will update the maximum with 4. Now we will check that if SM is less than 0, it is not, so we will not update it, and we will keep SM as it is, so it becomes 4. Now we will add -1 to it. We will add -1 to it. It becomes 3. Is 3 greater than mx? It is not the case. Is 3 less than 0? No, it is not the case. So we will keep SM as 3 only. Now we will add 2 to it. Okay. So we see that from this point we started getting positive numbers as a sum. Now we come to 2. We add 2 to value sum. We get 5. Is 5 greater than mx? Yes, it is. So we will go ahead and update mx with 5. Is 5 less than 0? No, it is not. We will keep 5 as it is. Now we will add 1. We get 6. Okay. Now we will go ahead and make this 6. Is 6 greater than the mx value? Yes, it is. So we will update the mx value. Is 6 less than 0? No, it is not. So we will not update the SM value. We will keep 6 as it is. Now we will add -5. So SM becomes 1. Is 1 greater than mx value? No, it is not. So we will keep 6 as it is. Is 1 less than 0? No, it is not. So we will keep SM as 1. Now we will add 4 to SM. 1 plus 4 becomes 5. Is 5 greater than mx? No, it is not. Is 5 less than 0? No, it is not. So we will keep SM as 5. So during the course of the iteration, we saw that at certain point we got 6 as the maximum sum of a sub-array. So whatever is the value of mx at the last of the traverse will become the value, and so we get the 6 as the answer of this particular sub-array. You can check this answer also. The output is 6. Okay. So this is the algorithm. This is known as Kanades algorithm, and this will also work for all negative values. Okay. So I'll tell you what the intuition is. So let's say if you have all the negative numbers, -2, -1, -3, -4. Okay. And initially the sum is 0. And initially you are assuming that the maximum value is -2. Okay. Now you start iterating with -2. -2 plus 0 gives you -2. Okay. You get -2. Is -2 greater than -2? Not making sense. We will not update it. But is the sum less than 0? Yes, it is. We will instantly make it 0. We jump to -1. 1 plus 0 plus -1 gives us -1. Is -1 greater than -2? Yes, it is. We will update it to -1. Is -1 less than 0? Yes, it is. We will update it to 0. Okay. Now we get -3. 0 plus -3 gives us -3. Is -3 greater than -1? No, it is not. So we will not update it. Is -3 greater than 0? Is -3 less than 0? Yes, it is. We will make this 0. We come to -4. We add -4 to 0. You get -4. Is -4 greater than -1? No, it is not. We will not change it. Is -4 less than 0? Yes, it is. We make it 0. And finally, you get -1 as your answer, because -1 is the only maximum subarray possible in this example. So it will also work for negative elements as well. So it is now time for us to write the code. Let us jump to the editor and write code for this. So I will first of all create a variable mx, okay, and I will assuming that the maximum value is at present at the 0 index. Now I will create one more variable sm that will store the sum. So initially the sum is 0. Now I will start iterating over each element of the array. So nums dot for each n. Now I will add n to the sum. Okay. Now I will check that whatever is the maximum value. So mx equals to math.max mx or the new sum value. If sm was less than 0, what to do? Make sm equals to 0. And at the last, return what we have to return. We have to return the maximum value. Okay, let us try to run this. Okay, this is working. Now let us try to submit it. Cool. So this was the algorithm. The time complexity of this algorithm would be big O of n because we are iterating over the array once. And the space complexity is big O of 1 because we are not using any extra space to store the elements. I hope you like this video. If you have any doubt for the question, do let me know in the comments. I'll be happy to answer. So this was all in this video. Till then, take care. Goodbye. See you in the next one.